Tuning a stepper motor for a plasma table may seem like a complicated process, but it really is pretty simple and is done in just a few minutes. The starting point will be after the motors are installed on the table and running on the correct axis. They must be properly configured in the configurator and have the X motor set to the X axis, Y motor and slave motor must be set to Y axis, and the Z motor set to Z axis. This is decided based on the orientation of the table. The first step is to find the diameter of the pinion gear on the motor you are tuning. You can usually find this on the spec sheet, but if needed, just measure it. Then multiply this number by pi, or 3.1416. Write this number down as your distance per revolution. Next, divide how many microsteps your stepper motor gets per rotation by your distance per revolution. If your motor is from CNC, it will get 2,000 microsteps. Doing this will give you your preliminary steps per inch. If you have belt reduction on your table, multiply your steps per inch by the amount of reduction. If, for example, you have 3:1 belt reduction, multiply by 3. Load CandCNC configurator and in the motor section, input the steps per inch you have obtained. Save and exit. If you are tuning an axis and its slave, input the same steps per inch into both axes. Now power on the blade runner and the motors, then load CandCNC. For the next steps in motor calibration, we will be using the MDI screen to enter a motion command and check that the axis moves in the right direction and the proper distance. The MDI is a section to allow you to type in direct G-code commands and to make the machine make specific moves. You don't need to have a deep knowledge of G-code to use it for testing. G-code commands are not case sensitive, but be sure to use zeros and not O's for the numbers. For the following steps, make sure your machine is in E-stop before continuing, otherwise you may get seriously injured. On your plasma table, remove the torch and either mount a laser or sharp-pointed tool in its place, or mount this beside the torch. Move this to a point on your table that you can mark as a reference point for measuring. Mark the spot as precisely as possible. Back in CandCNC in the MDI window, type in a distance to send that axis out using G-code. Here is an example. G1 Y40.0 F80. G1 is the command that means to move in a straight line. Y is the axis we are working on. And since we have a motor slave to Y, it moves its slave as well. F is the feed rate we will be using. Now, measure the actual distance traveled with a tape measure from 0 to the point where it stopped and write down the distance to as close a decimal as you can. Before you make any changes, move the axis back to the starting point in the MDI window. You have to do this before you change your steps per inch, otherwise you cannot go back to the same point again. Divide the commanded distance traveled by the actual distance traveled, then multiply the answer by the steps per inch. This will give you a more calibrated steps per inch. Close out CandCNC and open the configurator. Input the new steps per inch and repeat the test. Measure again and fine-tune the steps per inch until the actual and commanded distances are eyeball equal. Do this on all the axes. Keep in mind that the plasma flame does not perform a clean, precise cut, so an error of about 32 thousandths at the end of your test move is acceptable.